Welcome to Web Handling. My name is Dave Roisum. In the second clip in the series, we introduced the Abbott app called Wound Roll Sizer. This app is one of the most popular for good reasons. It can be used by anyone working with wound rolls and gives everyone working with wound rolls what they will need at some time or another. At its most basic level, you can calculate either roll length or roll diameter or web thickness, given the other two. While the calculation is not difficult for an engineer to derive, why bother an engineer when anyone can do the calculation? This app gives the essentials for anyone working with wound roll geometries. With a couple more simple inputs that anyone can easily get, and perhaps a bit of cleverness, this can also be used as a high-power engineering analysis tool. Let us begin with a basic question of how big your roll will be. We will use metric units and be in text mode, both selected by checking the appropriate boxes. Later we will demonstrate other modes. Let us suppose that we have a 1,000 meter long roll of 50 micron thick web wound on a 152 millimeter OD core. How big will the roll be? The answer is 294 millimeters. Simple. Enter in variables anyone would know and get an answer that everyone could use. Now let's take it a step further. Let us find out how heavy the roll is. We simply need to enter web width and web density, and we have it, just short of 60 kilograms. But you say, I don't know what the density of my web is. No problem. The question box will give you a table of the density of the most common materials. We entered 1.10 grams per cubic centimeter. That is on the high end for paper and in its mid-range for many films. Also note that in addition to roll weight, we can also get the basis weight of the web. That can also be a really useful thing to know. In summary, there is nothing on this screen that anyone working with webs would not know, with the possible exception of roll inertia used by drive people. However, if you don't need to know about inertia or basis weight or roll weight, you can totally ignore them. You are still left with a very useful roll size calculator. You can also use this app to convert an entire set of numbers from metric to US or vice versa, merely by checking the other box. We see that the 50 micron film is 2 mils thick, which is on the thick side for film, but on the thin side for paper. We also see that the wound rolls are small in diameter, but too large to lift by hand, even with 2 people. I can't imagine a single person working with wound rolls who could not use this app for a variety of uses. As I hinted, there is great engineering power in this calculator. We've already briefly mentioned roll inertia that the drive people would need. Here, we will do a winding study, in particular to answer the question of how tight is the roll wound. We use almost the same set of inputs as the previous example. Here, however, we note a discrepancy between the previously predicted 294 millimeter diameter roll and a carefully measured 304 millimeter actual diameter. Note that the modern winders can do this diameter measurement automatically with great accuracy, using a variety of methods discussed in the winding controls module of Web 101. So we will trial and error a thickness compensation factor until we get the right roll diameter. Note that this should always be set to 1.00 unless you are a winding expert, and then only with good reason, such as this analysis. A bit of trial and error shows that the thickness compensation factor of 1.09 gives the right outside diameter match. That means that the effective thickness in the wound roll is greater than that measured in the lab. The difference is in trained air that separates layers to some extent. Making use of what we learned in the winding theory module of Web 101, we know with film that the amount of air and tightness are monotonically connected. In other words, you cannot make the roll looser unless you allow more air in, and if you allow more air in the roll, it will get looser. Take care, however, that the measurements of web thickness must be quite accurate to do this kind of work. As we learned in the advanced winding section of Web 101, a better way to do this might be to simply weigh the rolls and compare densities. In summary, we could have an offline or online wound roll tightness measurement for film using readily available information and a calculator such as this. As we learned in the winding sections of Web 101, almost anything you screw up will show up on the side of the wound rolls. Sometimes this will show as a progressive bullseye pattern as shown here. Perhaps surprisingly, whatever caused this defect was upstream of the windup and had nothing to do with winding per se. This pattern could be caused by the raw material, an oscillator, or a drive as some common examples. What we want to know is the characteristic frequency or time or length of the disturbance. You can think of this as the fingerprint of the offender. So, given similar inputs as before, we note that one ring was at 249 millimeters and the next at 257 millimeters. Note that using 10 rings and dividing by 10 will give you much more accurate spacing, but the principle is still the same. In any case, we trial and error different lengths until the roll diameter, which is essentially the outer ring for this purpose, matches. In this example, we get 60 meters. We could look for a downweb FFT component of basis weight, thickness, or other measure with a fundamental at 60 meters. Alternatively, we might know that the machine is running at 60 meters per minute, and thus the disturbance frequency is 1 minute. We will let you adapt this tool to troubleshoot your own particular periodic problem. So while the app is so simple that even an operator can use it, you can still do some pretty high-powered engineering analysis with it. All you need is the right problem and the right knowledge and a bit of cleverness. Thank you so very much for watching this module in my Plant Practical series. Stay tuned for more clips on AbbottApps and other web handling topics.